So in this video we are going to discuss about how to implement a two input logic gate using MUX. Okay, so we know that first we will discuss about logic gates. What is logic gates? So there are different type of logic gates are there: AND, OR, XOR, then XNOR, then NAND, NOR, then NOT gate. So what is the logic behind the AND gate is if all the inputs are 1, then output is equal to 1. So this is the logic for AND gate. So for OR gate, if any one of the input is 1, then output is 1. For XOR gate, if the number of ones in the input is odd values, for example 1, 3, 5, etc., then output is 1. So XOR inverse is XNOR, that is if the number of ones in the input is even, that is 0, 2, 4, 6, etc., then the output is 1. For NAND gate is inverse of the output of AND gate. That is, if suppose the output of the AND gate is 1, means for NAND gate it is 0. Okay. So this is the inverse of the output of OR gate. Okay. So NOT is inverse of the input. Inverse of the input is your output. So this is your logic. Okay. So suppose consider if I want to implement XOR gate. Okay. So the question is implement two input XOR gate using 4:1 MUX and 2:1 MUX. Okay, so this is your question. So for this one you have to draw the truth table for XOR gate. So AB is your input, so this is your input, and this value is 0, sorry this value is 1 and this value is 2. So it ranges from 0, 1, 2, 3. So how to give 0? This is 1, This is 2 and this is 3. 2 plus 1 is 3. Okay. So this is how you have to write the input and output. Let me term that one as C. So what is the output? What is the logic behind the XOR gate? If the number of ones in the input is odd. So you can how many ones are there? So in this one there is no one, right? That is 0 ones are there. So the output is 0. So you can see here I am having odd number of ones because I am having only 1 1. So answer is 1. Here also 1 1. So here it is 2 ones. So 2 1 is even. So the output is 0. So this is your logic. So I can write C is equal to summation m 1 comma 2. Okay, this is how you have to write the equation. C of A comma B. Okay, C is your output, A, B is your input. That is equal to summation m. For 1 and 2 value, output is 1. Okay, or else you can write it like this: pi of m. This is capital M, this is small m. 0 comma 3. So the output is 0 for 0 and 3. Okay, so in 2 ways you can write. So next I need to implement this one in the 4:1 MUX. Okay, so what is 4:1 MUX means? 4 is nothing but your input and 1 is your output. Okay, so the formula is 2 power n is to 1 MUX. So here the n represent here it is 2, right? 2 power 2 is 4. So this n represent number of selection pin. So how many inputs are there? You have 4 inputs, 1 output. So for MUX means multiplier. For multiplexer, for multiplexer, always you have 1 output. Okay, always you have 1 output. So it's also called as many to 1 or data selector. So let me draw the diagram for the MUX. So you have only 1 output, that is C. Okay, and I can write you have 2 selection pin, so I can write this one as S1 and S0. This is your selection pin N, and you have 4 inputs. So I term it as I0, I1, I2 and I3. Okay, so we know that C is equal to, so the equation for the XOR gate. What is the equation for the XOR gate? C of A comma B is equal to summation m 1 comma 2. So for 1 and 2 you have to give 1 1, for the rest you have to give 0 0. So this is your output, right? 0 1 1 0 is the output of the XOR gate, and this one you have to term it as A and B. Okay, so what it represent means when A and B, okay, so I can write when A and B is 0 0, I0 gets selected. So when A and B is 0 0, so that is why I have given a bar. I0 is selected. So what is the value of I0? I0 is 0. So when the A and B is 0 1, I1 is selected. So 0 1, I1 is selected. What is the value of I1? It is 1. Next, when A and B is 1 0, that is AB bar, I2 is selected. I2 value is 1. So when AB is 1 1, I3 is selected, right? So AB is 1 1, I3 is selected. I3 value is 0. So C is equal to A bar B plus A B bar. So this is nothing but A XOR B. Okay. So this is how you have to implement the 2 input XOR gate using a 4:1 MUX. So next problem is, so this is your first problem, and second problem I need to implement this one in a 2:1 MUX. So you know that 2:1 MUX. 2:1 MUX means 2:1. So 2 is your input and 1 is your output, and n is equal to 1. It is a selection pin, right? So this is your selection pin. So this is I0 and this is I1 and this is your C. Okay. So you have to write I0, I1. What is the value of I0 and I1? You have to write like this: 0, 1, 2, 3. So we know that C of A comma B is equal to summation M 1 comma 2. So you have to mark this is your 1 and this is your 2. Okay, so this is your A bar and this is your A. Okay, so what is the value of so since I have only the circle in the second row and first column, so what is the value of this one? This is nothing but A. Okay, so here you can see what is the value. Here it is A bar. Okay, so I have to substitute I0 is equal to A and I1 is equal to A bar. So for selection pin you have to give it as B. Okay, so suppose if there is no circle means you have to give it as 0 if both circles are there. Suppose if I have 2 circles means the value is 1. Okay. So you can see C is equal to, when it is 0, the B is 0, A is selected, that is I0 is selected. When B is 1, I1 is selected. So I1 values, so this is nothing but A XOR B. So this is how you have to implement the logic gates using 4:1 MUX and 2:1 MUX. Thank you.